very warm welcome to one and all, our distinguished guests, my colleagues, dearest students, ladies and gentlemen, and if I'm missing out on anyone, then to all the esteemed participants of this webinar, a hearty welcome to you all. So as it is said, nothing can steal it, no authority can snatch it, not divided in brothers, not heavy to carry. As you consume or spend, it increases as you share. It expands. Education, Vidya as it is known in Hindi, is the best wealth among all the wealths anyone can have or possess. No one can steal it, as I said. And so we as torchbearers and instruments of imparting and sharing our knowledge with students and researchers on a daily basis truly believe that this notion of education, which indeed is the best gift that we have inherited and gained over the years from our parents, our teachers, our gurus, and of course, not to forget our life, which is perhaps the best teacher of all times. Ladies and gentlemen, my name is Anirudh Katyal, and I'm privileged to be a part of today's webinar being organized by Celestial Space Communication. My heartfelt gratitude to the team of Celestial for giving me this opportunity to moderate today's session. Celestial envisions itself as an organization of global standing, which fosters development of professionally competent talent and contributes to space programs and missions. With such a vision in our mind, it has taken another leap in this journey where it is launching a webinar series that gives us a chance to interact with and hear from the experts and researchers in the space fraternity. To add another feather to this hat, Celestial has come up with yet another interesting session of webinar, which is titled as The Waves, as was evident from the video which was being played and you all were watching it. And I'm delighted and honored to host today's webinar with the speaker as Mr. Mayank Sharma. Mr. Mayank? Yes. So Mr. Mayank, the founder and MD of Celestial Space Technologies, has come up with this exciting, interesting, I mean, I'm falling short of adjectives to describe this series of webinars that he and his team have come up with. But let me just give you a brief introduction about Mr. Mayank. So Mr. Mayank is the founder and MD of Celestial Space Communications, and he has done his bachelor's in aerospace engineering from University of Petroleum and Energy Studies back there in Delhi, in Dehradun, in India. Thereafter, he worked as a stress analyst with India's leading tech giant, TCS, and he was working there in Bangalore. Post which he took a giant leap and he started pursuing his master's. And so he did he's currently pursuing his master's in space engineering from TU Berlin. Thereafter, while pursuing his master's, he launched a startup by the name Celestial, and that's what has brought us here today. And since then, there has been no looking back, absolutely. So without further ado, I would like to hand over the proceedings to Mr. Mayank Sharma. And lastly, I would request you all to be as participative as possible. Keep posting in the chat box. And I would request you all to find out answers to all your questions from Mr. Mayank. He's there to answer all the questions that you have with you. And it's open for all the space enthusiasts. So there's no idea, there's no question which is wrong or right. A good question, something that will surely be answered by Mr. Mayank. So I guess over to you, Mr. Mayank.
Yeah.
Thank you so much.
Thank you. Yeah, thank you. Thank you for the introduction, for the warm introduction. And thank you for this huge number of participation that we are seeing in the first webinar. Frankly speaking, I was nervous, but there is really motivating. And as Anirudh said, please feel free to comment so that we could actually look at the questions and I could answer them, the queries. And this webinar is with the motivation to actually go for and explain more about space communication. We want to enable and we want to enhance space education, space awareness in the society, and this is our small attempt to actually do this with the educational sector. Since our entire team also belong to students, we are still students, right? So we are also trying to work on our own challenges, but we also want to work alongside the young graduates and young students who are trying to cross the barriers of and move into innovations. So yeah.
Thank you, man. Thank you so much for your words. And before I guess we proceed further, everybody looks very excited, and you can see that people have already started commenting as well. They've started participating. So I'm sure all the research enthusiasts would have this question that why celestial? So what is celestial space communication, and what is the concept of waves? And probably if you could also highlight your journey, maybe through a video or something, which can actually help us gain an insight into what celestial and the concept of waves is all about.
Yeah. So briefly about Celestial, although I have a presentation for this, I will go in there. But briefly explaining about Celestial. Celestial is basically a project that started from class. So it's a company that came out of a classroom, and this is also where we are now envisioning ourselves getting connected back to our roots. Celestial is working with students on analog missions. Igluna 2021. It's organized by Swiss Space Center, and we were also part of this mission, Igluna 2020. You should check this out. This is really very interesting and academic analog missions that happen in Switzerland. Apart from this, Celestial is really active in doing these kind of webinars now, and doing bringing this multiple multinational platforms all together. So we have experts, we know industrial experts, we are in contact with space agencies. So students who are facing problems, who have challenges, we can actually get them guidance, which expert guidance, which is really important at this stage, and help them in order to clarify their technological challenges. I mean, what we do with communication systems. So if there is a university tomorrow trying to do a space mission and are looking for space products off the shelf, I think it's better that they look for a team who is actually coming to their university, spending a week or week and a half and explaining stuff, making their student design this, and then procuring, manufacturing, and testing the hardware and the technology that has been developed. So this way, the main motive of this educational institute is education, which is fulfilled, and you also get to do a space mission. But I would also like to get into the presentation actually, where I have a video. Basically, so although it says is summer school, but this can also be done in winter. Just to clarify this over now, and basically this is
Terminology.
yeah. So this is what I was telling also. We are part of Igluna 2020, where Celestial was a participant, and out of that, this team has come out and got itself into a company now. The workshop really has 4 steps: link budget, small satellite antenna designs, circuit designs, and ground station design. And to this is just about my introduction. So yeah, I have been which is already done. I think it's not required so much, so we can skip that part. But this is the video of Celestial where we work together and all the technology developments that has happened. So just to give you a brief introduction what Celestial is.
Hi, my name is Johannes. This is my colleague Maya. We are Team Celestial and we develop space communication products and services. Our technology will target lunar missions, but it has also relevant applications for Earth missions and non-space sectors. The specific products that we're going to develop is a communication system based on SDR technology and also very systems are adaptive. They are in orbit reconfigurable. Our system provides ease for the complex satellite development process by offering flexibility in operating frequency. Our systems, the antenna systems, are additively manufactured, thus optimized performance can be realized by materials.
demonstration of S-band patch antenna and a steer-based communication system. Over here, the Celestial's two S-band patch antennas are integrated to a lunar lander, and the communication system has been integrated towards the inside of the lander. This is a lander system which will be here demonstrated for remote configurations based on the commands sent from the ground station. This is a ground station setup. Over here, the commands will be transmitted and the signals will be. So, yeah, so that's brief about what Celestial has been doing up until now.
We could even see you. So was that the actual moon where you actually landed up, or was it just a prototype?
No, this was actually kind of simulated environment of the moon, but this regolith that we were looking at, this was quite very similar to what you would find on the moon. And the lander, this is done by Planetary Transportation Systems here in Berlin, and we are very close with them. So they provided us the test bed, and we were able to test our technologies on a real moon lander with the real ground station we developed. So it was almost, I would say, very close to what really situation would look like. Yeah.
I'm sure if you wouldn't have said that, so a lot of us would have been fascinated, and we would have thought that, wow, if we associate ourselves with Celestial, we'd be probably on moon. So
yeah.
That's something, which is which every space enthusiast would look up to, Celestial, and I'm sure that one day it will no longer be a prototype and it will no longer be a simulation, but we'll probably have our team there and a lot of research enthusiasts who have joined us today. So maybe some of them will also make up to the actual moon surface also. So man, quite interestingly, as you were covering in your video also, and this seemed to have, it has given us a path to be a part of space missions or the lunar missions which have been conducted all across the globe. So we would love, in fact, to know from you that what is it that students can, or the researchers or the enthusiasts can look up to out of these webinars. Now, I agree that this is just an introductory session, and you were also showcasing some of these slides. So would you want to take us through this journey as to what one can expect in the coming sessions and what is it going to be all about? So we're looking forward to that.
So this session in the webinar, this is an introduction session actually. So the plan is not to cover any technical topics in this session. The technical topics will come in the part 2, where we will target link budget, where I will go in depth of the technicalities of link budget, and the session 3 or part 3 of this, where I will go in depth with basically the antenna designs overall. And this is also what this session is about. So this session is about explaining the overall structure of the workshop that we have designed. And I can actually share the presentation for this. This would already explain better what we are about to do actually. So coming to directly the workshop itself. So the main focus of having this summer school or workshop is basically a satellite and antenna development communication. So we want to start making the academics, researchers, and students more interested into space communications, explaining them the basic fundamentals from which our team also started learning all of this as a students. And the outcome we envision out of this is basically students would be able to build a mobile ground station which would actually be able to connect to the real space satellites. It's a real-time communication that they could do with the satellites, such as weather satellites, which are providing this open source signals and data. So you could receive it for your own region, for example. And then the outlook is basically this workshop has been developed in a way that we try to impart only the basic fundamentals, but more or less it's a hand-on experience workshop where we will actually move into practical applications of what has been explained in the presentation or in the classrooms, which include prototyping, software simulations, and then later on manufacturing and testing of these different technologies that are required to go for from idea stage to a real ground station and then a field campaign using this ground station that will be built to connect to the satellites in the low Earth orbit to actually get this data. And the requirements are basically if you're students and you have some professional background, technical background, this would be enough for us to actually go into that direction. And when we do this in the organization part, we are envisioning a group of 4 to 5 students with 2 laptops generally in between this group, and some lab equipment is required, testing equipment, development, prototyping equipment. So students lab would be another thing. And basically the 4 topics are envisioned to be covered in this. First one is link budget, then antenna design, then RF electronics. So it's not simple electronics, it's circuit design for RF front ends, which is also very technical thing, and then the ground station concept overall. In this webinar series, we will be covering only first 2 parts because we are trying to develop this web series still. And the further important thing is we want to see the interest that comes, and based on that, the further parts will be targeted in the later on stage. Regarding the link budget part, so this would be mainly presentation part where fundamentals of space communications, losses and gains will be explained. And then on the other side, there would be a practical part or tutorial part where a real case study example of a satellite which is in low Earth orbit would be targeted. And while we are doing this, they would be designing a communication calculations or link budget to calculate the link margin or the signal strength that they will achieve by using different off-the-shelf components, finding real off-the-shelf components that could be used in this design, and also calculating the power that this satellite provides and the kind of power their ground station would need based on various antenna designs and other things that they would select themselves. So we would only give them a case study that this is a satellite, you need to connect with this, what kind of ground stations you would build based on the link budget design. So they would have basically an overall knowledge about the infrastructure or the architecture of this communication that happens from ground station to satellite and vice versa. This is envisioned for 3 days duration, roughly 21 hours, and is an indoor application. Overall, this is majorly focused on giving students an idea about how signal travels and how the communication happens with satellite. Coming to the second part, which is basically the resources required for antenna design, is basically a student version or research version CST software, which is also what we use at this time as a students. And apart from this, the antenna prototypes will be procured and manufactured. In the lab, test equipments would be required. And idea is once the students they have designed their link budget, they would input some characteristics of the antennas that they find are available from off-the-shelf space companies are providing for their space missions. But now they would have to design the same antenna on this software and would try to get the comparable performance. So they learn how to design a space grade antenna and use it for their link budget calculations. And then we also go as a company, manufacture this, procure this, and give this for their mission that they want to do. So students not only do a space mission, but also learn the basics behind this, which is, I think, far better than what happens when you procure any antenna off the shelf and the students have no idea what are the fundamentals behind this until and unless they do this practically. So this is envisioned for 4 days, and this is basically indoor and a lab activity. And again, basically the requirements would come from link budget. What is the frequency? What is the gain they are targeting? What kind of polarization they are targeting, circular or linear? And based on that, they would be able to design this antenna for their mission actually. And we will verify this. We will get industries experts to verify this. So all of this will be in collaboration with the industry. So this is also where we add value actually, where industry and academics collaborate. Then there's a third part, which is basically RF circuit design. So during the link budget, students or the participants would generally select some kind of electronic RF components, and these RF components would then be input or would be selected out from the off-the-shelf available components or the companies providing these components. And then when they select these components, they would have to design a circuit for themselves, which would be a RF front-end circuit. This is a tricky part because RF electronics, it's a little bit different from what general electronics is, because signal leaks out. And for this, we will open source softwares like KiCad and Eagle, and they would be able to design this based on the real components that they will find. And then we would help them to design a circuit that has minimum losses After it is done, we would go for procurement and manufacturing of the components and circuit itself, which would end up into a lab test equipment, and we would verify their circuit design to be of minimum losses of what these softwares would generally give. So students would get an idea about the basic things they have to take care, because these were the things that also were the problem for us, and we had to face a lot of failed hardware because of this errors that occurred. And over the time, over 2 years, 2.5 years now, we have learned a lot of things, and this is what we are trying to give already to these students, so they don't have to go through failed hardware, and they are able to learn right from where we are already, and they're able to gain knowledge much faster. So the duration expected for this is again 4 days. It's an indoor activity, and mostly this is something like the antenna, circuit testing happening, lab activities, and development activities. The last part of this workshop is basically a ground station, which is remote. The idea is it's a mobile ground station, and a lot of hardware is required, lot of design. So design will be provided by us. What kind of design this ground station would look like. Overall, the circuit they would design, the antenna they have designed would be used in this ground station, and this would be based on the satellite that they want to connect. So there are some NOAA satellites, so weather satellites. There are also amateur satellites, amateur radio software equipment satellites. So these kind of satellites which are providing this signals and data right for free, and anybody can access this data. These ground station will be able to do that. And idea is that students will be able to get a real kind of ground station that could connect to real satellites. This would have a number of application. If somebody wants to do tomorrow a deep space observation antennas or deep space observation ground station to observe radio signals from these celestial bodies, this is also a part of this ground station. I mean, they could easily move from this to that ground station applications, but they would know the basics. And we are envisioning 10 days for this kind of workshop. It would be indoor and outdoor, because this would be a kind of field campaign. And what we would give is signal reception. So we would tell them this kind of satellites exist, and they would use these satellites and the information provided for signal reception and everything, the software needed, firmware needed for this ground station. And a good example of this, what's happening is with the SatNogs, they have really small ground stations, and something similar we would design for them. Coming to the overall how this would look like. So we think this is roughly a 3-week working, so 1 month overall workshop, with the 3 days for link budget, 4 days for antenna design, then 4 days for firmware design, and then the 10 days for ground station design overall. And the first workshop is in the final rounds of discussion with Swiss Space Center at this time, and they already like the idea. There is a positive response we have, and we are trying to organize this first workshop at ETS Zurich, hopefully. And this is already in the final rounds, and soon, I believe soon we will go into contract signing with them to do this in probably in March. Now coming to the topics that we will target now. So in the webinars, now the webinar that will happen on 28th would be on link budget. And this is the topic that I would be explaining in those webinars. First is basically what are the critical factors and assumptions people would assume while they're designing link budgets for satellite. What happens when you are doing transmission and reception, and what kind of architecture it looks like. The antennas, and what is the various RF components like low noise amplifiers, how you read data sheets, how you assess and incorporate these values from the datasheet into your link budget calculations. What are the noise sources? What are the errors that could happen, and how you can mitigate them? Basically, polarization. What is the significant? What are the various type of polarization? Why it is significant? And what happens when you become careless with these kind of topics over there? And modulation schemes, there are many type of modulation scheme. Why we select modulation scheme, and why certain kind of modulation schemes are preferred over certain kind for a different kind of mission or for a specific mission. So overall, what we envision is we want to go theoretical in the webinars. We don't want to go practical, because it's 45 minutes, 1 hour, and it's not enough time for us to explain all of it. But to give or start having participants or generate the interest in these topics, we would already give them the overall knowledge about what this is on a very broad level, and how to evaluate this. But on the tutorial level, we will actually go into the case study And this is what is important. We will tell them we will already put one of the case study in the picture, and they could actually go into detail from the resources we will share with them, and they can then send me back their solutions, and I would be happy to answer them. So a practical approach, but a distant one, I would say, not very focused. On the second topic, which is antennas, so we will explain them the antenna types, antenna fundamentals, various patch antenna types, because this is what satellites generally use. And then the software introduction, the CST, although there are many introductions available, but I would also share some specific material on this. And then later on, how you tune antennas, because this is where the tricky part comes. You can get to an antenna with very general formulas available, but tuning of antenna is a tricky part, and this is where we will explain them our learnings, our own methodology. So I was a little bit in a problem when I was designing my antennas. So we designed our own methodology to reach to an antenna, and I would be happy to share that so that the students find it easy to work with. And then at the end, we would share a little bit of performance enhancement techniques, based on which we have also used few of those in our studies, and they are pretty effective. And at the end, again, based on the link budget design, I would formulate one of the problem statement, and I would share it on my tutorial. And those who are interested, I would also let them know where they can find this online free softwares. As a students, they can learn a lot of things from them, and they could send it to me, and I would be happy to give them feedback, organize a call, and help them out. So overall, the webinars would be more or less theoretical, but those who are more interested in knowing more and doing more, I will also have an option for them to actually go a little bit one step ahead and do some practical work with me. This is my contact details, just for the reference. If those who are watching can note it down, in case you want to contact in the future, please feel free. I would be happy to contact with you and get back to you. Also discuss ideas. I'm open for all of this. So yeah, overall, that's basically the presentation.
All right. Thank you so much, man. Thank you so
Yeah.
much for that. It was quite an impressive presentation, and it gave us an insight as to what we can expect over the next 20 days, 30 days, when we have the other two sessions which are scheduled, which I'm sure are going to be more technical, because this one is just an introductory session. And
Yeah.
I'm sure the other two are going to be more technical, I would say. And this would also provide a very good opportunity, because I was reading through some of the comments, and already people have started liking your idea, and they've already started sharing their inputs, and have started seeking your input also as to how these antennas, how the shaped antennas can be used in telecommunication satellites, and of course, what are the possible link budget calculations. So I'm sure we are going to cover all these. Just to answer to our viewers, we are surely going to cover these aspects in the coming to webinars, and I would invite you all to be there back with us, and explore more about what are the technicalities which are involved into this. Mike, there's a question which has been put up, and there are people who are new to this field and want to learn more about this, so they've already started asking you for some useful material that can be provided to them. So what are your inputs onto this? I mean, what kind of material or what kind of support would you want to help people out with? The ones who are looking for shaped antenna for telecommunication satellite, and for the people who are new to this but are willing to explore more about it. What are your thoughts on this?
Yeah. So yes, this is already really nice comment. I think nice question. I was expecting such questions already. I think it's a very exciting field if you are in space communication, and I'm here to help you. As a founder, and as a person who knows now a little bit about the space industry and what is happening latest in the space industry, I am really happy to actually get back on this topic and help you guys. So there are a lot of topics, lot of resources available online for link budget, for antenna design. I'm happy to share my own experience, how I started and how I have built my own antennas and my own link budgets, and created even the space mission architectures for moon missions. Apart from this, if I shared with you already my details, where I shared my contact details. You can always follow up. Send me a message with your questions. I'll be happy to answer. Also share some material if you want. But more or less, this would be what I can support with. I can support you with my own personal time and help you channel your interest into the right direction.
Okay. That's so nice of you and your team to have, already gained the confidence which you wanted to in your audience. So again, thank you so much for that. And so, like, there was also another question that for link budget calculation, if you could share some more examples for the low Earth orbit satellites in worst case tracking. So, what are your thoughts on this? What are your inputs on that?
Yeah, definitely. So this is also my interest actually. Although I will not go in the worst case scenario on the first day, because this might be damaging to the confidence of a person starting to learn. But there are critical and worst case scenarios with the satellite communication, especially for example when the satellite is on horizon. It's not vertically up. You are covering more distance in the atmosphere. So this is taking into account more losses. But for this, there are already existing tables and tools to calculate link budget. What I will do is I will explain you how these tools work, and I will also explain you the science behind these calculations and formulas used, and you will have a good understanding of these worst case scenarios. Once you are able to do your first, I would say, a basic link budget, which is not very difficult and not very hard. I would then actually be interested to share with you probably another problem statement that would be a step ahead, and you guys can actually target this from a different angle, because I can also set a limitations on some kind of antennas that you cannot use. This would also scale this problem to a next level. So this could be really creative problems. So I could also create these kind of creative problems for you, and then you guys can actually go for it. And I would be happy to give you feedback, even probably help you designing your link budgets in the future. Yeah.
Yeah.
Okay.
So,
So
yeah, so I'm there.
yeah. Okay. Okay.
It was so good to hear from you that I had to actually put on my microphone and mute and video off because it is such a pleasure to hear from you. So, thank you so much, Mayank, for answering that as well. So, there's another question that do you include the MIMO antenna and the related topics to the presentation? So, are you going to cover them as well in your future modules or future webinars?
Yeah, so I will actually cover these in theoretical part. As far as the practical part is concerned, I would start slow. I wouldn't press this too much. But yes, I can share questions. I can share with you the problems and the advantages happening, and you're free to explore this. So, I mean, basically, I will not drive the people to explore more. I would only give them suggestions, and they are more than welcome to drive themselves, and I will support this drive. I will support with everything that they are trying to do beyond the scope of this workshop. And this would be my interest. I would like to see a few people doing that with me. And then, yeah, of course. And this also gives me idea what kind of talent is out there and how to collaborate with better with them. So yeah, I will include some MIMO antennas, so multiple input and multiple output antennas. And but just to be clear, I won't be going into phased array antennas, because this is whole new level. So I will only restrict myself to limited antennas for now. Yeah.
All right. Okay. All right. So I think it's very well clear to all the young enthusiasts that what are the topics that are going to be covered. And in fact, Mayank has thrown a little insight as to what they can expect in the future webinars also. So do you have any views on the reusability of the satellites also? I know it's a very generic question, but quite an interesting one. Even I was also looking forward to ask you. So
Yeah.
can you
Yeah.
throw some light on the
I think
reusability,
I think
especially?
after reusability of rockets, time has come that we start reusing satellites, because we saw what happened with this, and this is why companies like us are coming into picture, because space has become privatized, and now I think the time has come that we start reusing satellite, and this is what our vision is. Also, we want to develop communication systems, and we want to develop antenna systems that are able to withstand multiple orbits, and that are able to withstand multiple frequency schemes, and multiple software and ground station applications, so they can connect to any ground station anywhere, which will give them the ability to be reused on a different orbit for a different application. So you don't have to manufacture this, you don't have to test this, you don't have to procure and launch this satellite, which is also the major cost drivers of any space mission. So you already have a satellite and you're reusing it. This also brings into picture. Yeah.
Overhauling this is done for the aircrafts and for the various systems. So it's just like overhauling of the satellite, I would say.
Not exactly. I mean, you won't be overhauling because satellite is in orbit. You won't be touching it and doing anything on this. But the idea is you send a satellite that is able to work for 6 years or 10 years without overhauling, and you use it for different applications directly. So you give it a one flight, and that is done. And your industry partners or your academic partners could use it once you are done with your satellite. So this also gives an opportunity to collaborate and work on it together, and bring this satellite development cost below. Because as I tell you, the vision that we started with is basically to bring down the threshold of space missions and to bring down the threshold of moon missions. I want to see students doing moon missions, and for that I want to see people are able to send missions on a low cost to moon, because that is the only way it is possible. And now low cost mission is CubeSat mission, and I want people to do this CubeSat mission for moon, so that they are able to do this from classroom. Because I envision, as a student, I think there is more potential to innovations in classroom, because students, they don't know where the boundaries of human knowledge lies, and they cross it, and there is where innovations happen. And this is where we want to provide a communication infrastructure on the moon, so that these small satellites are able to do this moon missions, because this is something we couldn't do in our time, and we had to come up with the different solutions. But if there is a infrastructure on the moon, then I would say yes, there is a possibility of doing a CubeSat moon mission. And this is also where you get students doing moon mission. Never happened before in the history.
I'm sure I'll have to Google a lot of terms today in order to get more depth and insight into what all you spoke about. So you seem to have connected economics to space as well when you talk about optimizing your resources, lowering down the cost, threshold, achieving the threshold at low cost. So this altogether shapes up a new subject of space economics, I would say. And we're getting a lot of good insights also. In fact, some of them have already started commenting that they are looking forward to collaborate with Celestial and expand their knowledge. And so there's one more question that is quite interesting, and I would want to know from you if there are any limitations to the design of antenna related to the coordination frequency. So what are your thoughts on it? How is it achievable, and what do you think are the limitations which are there?
Yeah. So the antenna is basically an open circuit. The current flows, and since it is an open circuit, it radiates out. That's what basic principle of antenna is. And yes, there are limitations. Now, this will be covered in my third part on 13th of January, but 2021, just to be clear. But coming to the topic itself, I think antennas are highly complex designs. They are very complex, because in my experience, when I was working with them, I would change very minute detail on the antenna, and my entire definition of antenna would change. So they are very sensitive. This is the most concern that you should be with the antenna while designing it, because they are very sensitive and complex hardware. But coming to the limitations now, yes, antennas have limitations. A particular kind of antenna will only have a particular kind of radiation pattern. So it will only radiate either everywhere or one side. And even if it is radiating everywhere, then you lose power on that, because you only want to communicate in one direction. Generally your satellite is in one location, right? So that's one part of it. So coming second part, when you are targeting a particular frequency with a particular antenna, then this antenna will only work on this limited frequency. And now your target is to have more bandwidth on this antenna, which means, so to say, giving an example of a road. Now there are 6-line road, there is 2-line road, right? Now you want to travel on a highway. Highways are generally large number of roads, like 6-line, 4-line road, right? So this is bandwidth. 4 cars can go, 2 cars can go. Okay, that's what bandwidth is generally. Now, if you have an antenna, it will have a particular bandwidth. As an antenna designer, your aim is to keep your antenna on that frequency and broaden the road, so that more data can flow. Now, this is a limitation. You can only reach to a particular level. You cannot go beyond that level, because there comes the physics. Physically, there is crossing a limitation now. Now, this is again up to you. If you become innovative on that design, you can actually cross this barrier. So giving you another example, you have a patch antenna, and this is a directional antenna. The direction it is looking at, it will only communicate in that direction. But now you want to communicate everywhere, so use 2 antennas looking back to back each other. Now this antenna will communicate this direction, this will that direction. So that's innovative or smartness in design, not in innovation, but smartness in the design. So it's up to you how you tackle your problems and get to the solution. you have to get to particular solution to answer what kind of um, requirement is there, and you have to answer that. You have to get to this here, either you get like this or like this. Nobody cares. You need to reach here. That's the idea.
So I guess to all the participants of this webinar and those who are going to attend the future webinars, I'm sure you're going to catch hold of a lot of analogies which Mayank is going to
I
throw
hope
just
so.
through highways. And I could even imagine the two antennas standing right rear after rear to each other. So I could think of two cars which were standing, with their bonnets on the other two sides, which were not facing each other. So that's somehow that also helps us to understand the analogies and understand the technicalities in more detail. And I'm sure these analogies are going to help a lot of people who do not even come from very technical backgrounds or who are not very tech savvy. So we're looking forward to that. And then there's another question which has come up to us, that which of these active switches are preferable for switching in multiple input, multiple output configuration antennas and satellites. So if you could probably throw some light on that as well.
Yeah. So largely, there is a new trend in the antennas to have, as I will also correlate this to the previous question. There is right now what scientists or what engineers are trying to do is to have multiple frequencies in the antenna. So they want to have multiple inputs into the antenna. So you switch the input and you are able to communicate on different frequency levels, right? So right now what happens is most of the people, or most of the technology uses diodes, because MEMS switches, they are having more or less signal losses, or they have higher insertion losses. This having said that, uh, MEMS switches give more flexibility into the usage of this antenna, as far as I have used them. And diodes, they are pretty much, once you fix this, they are working on off. But then this is how people design now, because you can be very creative with your design, and you can use multiple diodes on multiple levels, so that you are able to switch your signal going to this antenna from one port to the second port. So that way you can work with this. But it depends really on the application you are trying to target, and what kind of solution fits best.
Absolutely. So it's more about application oriented and what. So there's no one thing which fits all the sizes. So you need to play around with it. You need to customize. You need to personalize, and then whatever works the best for you, that whatever serves your application. So that's more important, that which factor you choose in that. Absolutely, Mayank. That's so good to hear from you about the types of switches which can be used in MIMO antennas as well. So that's one. And now I guess I would want to move to certain questions. You've already covered a lot of questions. You've already answered a lot of questions which are tech related, and I have come up with a terminology which is techivity, which means a blend of technology and creativity. And already people have started commenting that your Celestial has the substantial potential to go ahead and advance into the space program. And of course, with the effort from your team, and of course from a lot of collaborators who have already joined us, a lot of researchers, space enthusiasts who are there, sure Celestial is going to reach wonderful heights in coming future. But Mayank, I have another question. Now, this is somewhat not related to the technical side, and I was going through the comment section, and a lot of people want to know about your journey. So, what have been the hardships? And I'm sure this is an out of syllabus question for you, because I'm sure you would have prepared for the technical ground, but I'm asking you a non-technical question. But I would want to know that what have been the hurdles, the hardships, the opportunities, and how you were able to grab them to come up with the organization like Celestial.
Yeah, sure. So I think people won't be interested in knowing my story, actually, as per se, but a story of a student who made a company.
Certainly interested in knowing your story more than the antennas.
I think more sense would be to actually tell them how a student was able to create a company. I would say the first part is be ready to fail. This was my task, and this is also still my aim. I'm trying to do things which I think I cannot do, and somehow I'm not failing, but also somehow it's surviving. This has been there. And secondly, I would say try to be in a risky area, uncomfortable zone, because this is where you are able to work hard on your goals, and you will be able to live. I mean, it's a saying: if you need something as bad as oxygen, you will get it. That's the motto. And in Celestial, we have won some international awards now. Celestial has also been part of a lot of acceleration programs. We are currently incubated at European Space Agency Incubation Center, Business Incubation Center. So we are in very close connections with European Space Agency. We are also in very close connections with the Swiss Space Center, for that matter. So apart from this, now we will be going for our subsidiary or a second daughter company in Luxembourg, where we have been offered another accelerator program and a chance to explore. This is where now the array antennas will start from our side. But the good part about this is we just have completed our first antenna, and we will be launching this on satellite to low Earth orbit, and this will happen in the middle of next year. So within 2 years, 2.5 years, we have already created a technology, a system for real space mission. That's the learning I have. So I think this would help the viewers to understand the knowledge that we are bringing with ourselves, and how we are able to design it. Yeah.
All right. So there's this very interesting question that has come up, that how can the students get to collaborate with you? Because you mentioned about the physical training programs, the practices, the practical things which you are going to cover, which are not going to be the part of the webinar do. But how
Yeah.
do you think that you will be able to collaborate with the students through the universities, or without the interference of the universities also, if there are any participants? And before you
Um,
answer this question, I think I want to quickly get through some of the technical questions. So, for steerable antenna in Ka band, I want to know if you can share some simulation next time. Is that a feasibility? Is that possible to share simulation?
yeah, I think I can share some simulations. I also did a lot of work on patch antennas, but frankly, I haven't done any simulations up until now for steerable antennas in Ka band. This wouldn't be with me, but sure, I can share with you. If you have any problem, I can get you an answer. I can help you connect with some kind of expert. This is also what we will do for you. So if you have some kind of problems that you are facing with this, I can help you get in contact with some experts, or I will try to get an answer for you, and I will get back to you. This is always in the question. So even if I have not done something, because I'm still starting, it's just 2 years, very young on this field. And if you need some kind of assistance and help, I know people who are much bigger giants and have a lot of knowledge than me. So I would be happy to get you in contact and have you get the answers for this kind of questions. That won't be a problem.
All right. So it's not just about a collaboration with one or two people. You have a list of experts on board with you, and that's what you are looking forward to. And of course, now I would want to get back to the question which I just asked you. What are the opportunities for the students for collaborations with Celestial?
Yeah. So as I said, currently we are collaborating with the universities for analog mission with Technical University Berlin and all. But what I want to say here is, if there are students and there are academic teachers and professors who are listening to this, um, if you're doing a space mission, or if not, and you're designing an antenna, for example, then our team is really interested to collaborate with you, to give you a dedicated workshop just on the antenna, ignoring the link budget and ground station design. So you can also pick up one part of it, and we can help you design based on the mission requirements. And then we will verify this with ourselves from industry, and you will also verify this with ourselves. Once everybody is satisfied and we see it's fulfilling the requirements, we will actually move into the procurement and manufacturing of this antenna and testing on our level, and we will provide you a finished product with the space grade coatings and with space grade material applications on this. So this is what we can also collaborate. Apart from this, if you have a general question on any team, I'm happy to answer this on general level. This is also not a problem. This is also my interest to work with the academics. Yeah.
Well, now I see that more than the number of questions, there are all praises and appreciations for you and your team. So a lot of people have already started finding it very interactive. So we are really looking forward to more of such webinars in future also. So thank
Yeah.
you, Mayank, for that. And I guess now as we head towards the closing of this session, so I would personally want to put up a couple of interesting questions to you and seek your answers on it. So I would I would want to ask you that as you said that from classroom to company was one concept, and then you also said that be ready to fail.
Yeah.
So I would want to ask you that who has been your or what has been your inspiration, and how were you able to launch this company, the Celestial, into the space sector? So talk us
Yeah.
about, take us through your inspiration and your motivation behind this.
Yeah. I actually I'm really inspired by what I would say. Um, Whenever I'm in a problem, I do imagine my mother here. I think she is the one who's inspiring me. I have been around a lot of people who are successful, but I think that's they do not they're not as close to me, right, as my mother. And I've seen her working. I think females should be more. They should be. This is why I think the female section should be promoted more into space industry. I think they have different kind of capabilities that can be very advantageous to overall space exploration. This is a humanity, and we have to explore space together. So I think this one section, which is still, I think, finds some kind of challenges in reaching out to the level in space industry that they deserve, should be promoted. And yeah, that's basically it. But other than that, it's just me doing stuff, and then yeah,
I
that's
mean,
it.
I would be modest of you to mention, the creator of you, your mother, who has been the inspiration, and of course, you've given due credits to the female fraternity as well. And I'm sure all the females who would be watching this would be super excited to collaborate with you because you've already thrown a platform and opportunity out to
Yeah.
them.
Yeah,
So
that's fact actually. So I'm talking only fact. I'm not here being any sentimental. That's the fact about me. Yeah.
all right. Thank you so much, Mayank, for I would say for empowering the feminism, the female sector, because you don't find a lot of females being active members of space missions. Of course, in the past we have had a lot of women who have jumped up and who have grabbed this opportunity, and of course we cannot turn blind eye to a couple of women who have been into the space as well from India and of course from various other countries, and a lot of missions which have space explorations which involve space explorations have had the honor of having female participation onto it as
Yeah.
well. And sure, we are looking forward to more of such participation.
Yeah.
We also want to have a society where nobody is treated inferior and there's nobody who lacks the opportunity just on the basis of sentiments or on the basis of grounds of demographic details.
Exactly.
Definitely. So I guess a lot of people are looking forward to your future sessions as well, and I guess I would want to close out with your remarks only. So anything that you want us to get back onto you? Do you want the participants to share some kind of feedback with you? Do you want the participants to actually get in touch with you? And what are the possible mechanisms for them apart from the email ID that you've shared?
Yeah.
So
So we will actually send out a small survey form, just 8 questions or so, just objective types, and you can just help us answer, understand if there is something that you would like to know more. Apart from this, there will be a follow-up mail with more information. Yeah.
connect with you in a better manner. I mean, because there are a lot of questions which people want to ask. So you mean to say there's going to be a survey form which is going to be rolled out to all the participants?
Exactly. And
All right.
apart from this, we will also be sharing the details for the second session that is organized on 28th of December. So please feel free to join that. This is also free. So this is entire series is free. And if there are more people coming together and we see more participation, we would might actually extend this webinar series, or we could have this webinar series again on different questions or different topics. So yeah, be active participants to this, and help us to help you. Yeah.
All right, Mayank, thank you so much. I'm pretty sure that you will have to organize more of such sessions because there's going to be a long queues of demands which are going to come to your organization to organize more of these sessions and educate us all on various topics which are related to space engineering. Thank you so much, Mayank. With this, I would want to congratulate you and your team for being a part of this exciting mission of not just making profits or thinking of making profits, but also distributing the most important wealth which we all possess, as I also said in the starting of the webinar, which is education. Thank you so much, Mayank, and we would love to even know about your team as we move towards the end of the session.
Yeah. Oh, thank you very much. And thank you everybody for being here, and hope to see you again on 20th December. Thank you.